Greetings, this is Mr. Garwood with our continuing video series on Calculus 2nd edition by Briggs, Cochran, and Gillette. This video is continuing our conversation on the chain rule. This video is going to focus on finding the derivatives of powers and rational powers as well as rational functions using the chain rule. So our first example here, we're looking at f of x equals the square root of 5x squared plus 1. I have highlighted the 5x squared plus 1 because that is the composite function that I want to break out. So what I'm going to do is I'm going to come over here and I'm going to say that u is 5x squared plus 1. And what that allows me to do is to come over here and say, oh, well, if f of x is that, but u is defined as 5x squared plus 1, well, then f of u is just the square root of u. Now, my first step, I'm going to evaluate the derivative du dx. Using our power rule and other properties of derivatives, I know that the derivative of 5x squared is 10x, the derivative of 1 is 0, so du dx is 10x. Evaluating the square root is a little more tedious, and what makes this easier is if I will rewrite the square root of u as u to the 1/2 power. And now that I have that, what I can actually do is apply the power rule. Well, so what do I do with the power rule? I multiply the front by the old exponent, and then that's u. I subtract 1 from that, so 1/2 minus 1 is negative 1/2, which really means that this is 1 all over 2 times u to the 1/2, which can be written as 1 over 2 times the square root of u. And so there's my derivative. Now, to evaluate the derivative of f, with respect to f, so I've got df dx equals, well, df dx is df du times du dx. And I know I mentioned this in the last video. I really love the idea of, well, if I just make the du's cancel each other, I'm still left with dx dx. I think that's really useful to think about. So, well, df du we said was 1 over 2 times the square root of u, and du dx is 10x. So now I'm going to start putting this all together. We'll finish this out in blue. I've got 10x on top over 2 times the square root, and I'm going to go ahead and substitute back in for u. So I've got 5x squared plus 1. Now, what is nice here, 10 divided by 2 is 5. So I've got 5x on top over the square root 5x squared plus 1. So, and that's it. I'm done. I'm not going to simplify that anymore. So that is our example that involved a radical. And I'm going to run through the example here where g of x, that's an x, is 1 over x squared plus 1. So my goal here is I've got to figure out what's the ugly function and what can I break out. What I'm going to note here is, and I'm going to write this part in the bottom again in blue so I can really separate it out and get you to see, I'm going to define u as x squared plus 1, which means that g of u is just 1 over u. So, the derivative of u with respect to x is 2x. And now I'm going to have to evaluate this. Just like I did before with the square root of u as u to the 1/2, I'm going to define 1 over u as u, that's horrible, u to the negative 1 power. Just like before, using the power rule, I multiply by negative 1 because that's the exponent, and I subtract 1 from negative 1, giving me to the power of negative 2, which means that dg dg du is -1 over u squared. Now, from here, df dx, or excuse me, dg dx is dg du, and I did that in the reverse colors, times du dx. dg du, and let's do this in the right color this time, is -1 over u squared. du dx is 2x. Now combining these, I've got -2x on top, and I've got u squared on bottom, but u is x squared plus 1 all squared. And that takes care of it. So this is just all about finding the u, taking it out, taking its derivative, finding the new function, or the decompositive function, finding its derivative, and just multiplying those two together. I hope you found this video useful, and good luck as our semester continues.